So a quick overview of rational versus irrational first. When you think of rational numbers, think of that word ratio in it. So ratio means fraction. So anything that can be written as a fraction is a rational number. So for example, 2/3. It can be negative, -5/7. It could be whole numbers like 3 because you could write this as 3 divided by 1. As it could be zero point 0.2 because that's 2/10. Any decimal that stops like 0.123, that's 123 thousandths, right? So this is versus your irrational numbers, and you're like, okay, well, what numbers can't be written as a fraction? Well, these are your never-ending non-repeating decimals. Never-ending non-repeating decimals. So if you had, so like point, even if like point some kind of random stuff, la la la, and it just didn't stop, you can't write that as a fraction. Classic examples of irrational numbers are pi, because that's like 3.14 dot, 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 never ends, doesn't end up repeating. So that's irrational. And imperfect square roots, like the square root of 2 or the square root of 5, are irrational. Perfect ones, like if you had the square root of 49 and you know that's 7, that's fine, that's rational. But if it's not perfect, we can prove that it's irrational, that you can't make a fraction out of it. It's pretty cool. All right. So with that said, taking a look at these, I know that the square root of 9 is 3. So 1 divided by the square root of 9 is the same thing as 1 divided by 3. That's a fraction. That's a ratio. That's rational. Square root of 17, though, that is not pretty. Closest thing I can get is square root of 16 is 4. Square root of 25 is 5. Square root of 17 is no good. It's irrational. That's a fraction staring me in the face, right? That's rational. This guy, it stops. I can write that as a fraction, no problem. That's tenths, hundredths, thousandths. That's 423 thousandths. That's rational. Check.